G'day everyone, welcome to Lubrication Explained. In this video we're going to talk about the synthesis of synthetic esters. So the first thing we'll talk about is obviously the synthesis, and we'll also get into properties, but just a little bit. There are such a huge variety of esters that are out there in the marketplace, and so we really need to dedicate a few different videos to properties as well as applications. So in previous videos we talked about the differences between mineral and synthetic base stocks. And one of the things that we did, especially in the PAO discussion, was to talk about all the different groups of particularly mineral base oils on this scale that kind of had aromatics, naphthenes, and paraffins. And we said that the process of refining from a group 1 to group 3 is to get slowly more paraffinic in composition. And group 4 PAOs represent in some ways the end point of that refining process, in that they are purely paraffinic. Now this paradigm doesn't really apply to ester synthetic base stocks, right? That you can't really categorize them in this way. So let's go back to what an ester is. You probably learned about this one in high school chemistry. So the way that you make an ester is you take an acid, you react it with an alcohol, and that will give you an ester and water. Now esters are widely used not just in the lubricants market, but everywhere. There are a lot of vegetable oils which are effectively esters. Esters can also be quite aromatic, so a lot of synthetic flavors and aromas are built from esters. So the classic high school science experiment is to sort of make the banana smelling ester. And so it's a relatively simple reaction. Now what does that look like practically? So if I took an acid functional group, so here we've got a carboxylic acid, and you react it with an alcohol, what you get is an ester functional group as well as water. So this is kind of what that process looks like. However, we know that there are an infinite number of acids out there and an infinite number of alcohols out there. So that gives us an infinite combinations of ester. So what might that look like in the lubricants market? Well, let's go through a couple of types of esters that you may have heard of. So if I were to react a mono acid with a mono alcohol, what I get is a monoester. However, if I react a diacid with a mono alcohol, what I get is a diester. Now the full name is dibasic ester, but commonly they're just called diesters. You'll see these in compressor oils and jet oils in particular. Right, so a really common base oil that's out in the market. You can also react a mono acid with a polyalcohol to get you not a polyester, so we're not making plastic clothing, but a polyol ester, which you might be very familiar with. They're very common fire retardant lubricants, have really good high temperature performance properties, and almost all of the modern jet oils, for example, so the aviation lubricants, are almost always polyol esters. So let's go back to the idea of a diester, and let's look at the synthesis in detail. So what I need is an acid, an alcohol, and an ester. So let's start with what a diacid is. So if you remember, we had this carboxylic acid, so it's an organic acid. This would be a monoacid, and a diacid is just one in which it has two of those acid functional groups. Right, so we can represent the R, of course, is the some kind of polymer, and this diacid has two functional acid groups on either end. Now we're going to react that with a mono alcohol, so it only has one alcohol functional group, but for the purposes of this demonstration I do need two of them. And when you react these together, what you get is a diacid and water. Sorry, a diester and water. Now, this is a very oversimplified demonstration. So let's look at the diacid in particular in a little bit more detail. So what does the diacid look like? Well, it probably looks a little bit something more like this. So there are two ester functional groups. That's why we're calling it a diester. And in between, we have that R, which is some number of saturated carbons. When I say saturated, it's because they're all single carbon bonds, right? Now, the N there, I'm saying there could be 1, 2, 3, or even 10 of these carbons. And the number of carbons that sits in between the ester functional groups dictates the name. So you may have heard of an adipate ester, for example, or an azolate ester. That's really referring to the number of saturated carbons that sits in between the ester functional groups. So an adipate ester, for example, has 4 saturated carbons that sit in between. Okay, so that's dibasic esters. Now, as I said, there are an infinite array of esters, and we can organize them by, reacting with short chain fatty acids, long chain fatty acids, branched fatty acids, all kinds of different alcohols, and we can get different esters. So maybe if we go into some of the more familiar ones, there's a phthalate ester, which would have an aromatic ring and 2 ester functional groups that come off it. Or, as we kind of have alluded to in the past, polyol esters, where you have a central carbon and it is surrounded by ester functional groups. So, even just in these 3 very common lubricant ester examples, we can see that you can arrange esters in many, many, many different ways. Now, if we were just to pick up on these 3, something that you'll notice in common, there are a lot of carbon-oxygen bonds, so that's likely to make these much more polar molecules than, say, the mineral oils or the polyalpha olefins. So esters tend to be much more polar, and for that reason they have really good additive solvency. They also bond to metal surfaces really well, and that's going to be important when we talk about esters in the elastohydrodynamic lubrication regime. One other thing, most of the carbons are saturated, so they have very good oxidative stability. They also have very good thermal stability, although that's a little bit dependent on the nature of what we're going to call the secondary carbon. So I'll get into that in a little bit more detail in a future video, but it's one of the things that really distinguishes the diesters from the polyol esters. So yeah, that's been an introduction into ester synthesis. We will get into much more detail about the properties and how they function in future videos. But in the meantime, as always, if you have questions or comments, please leave them down in the comment section below. Otherwise, this has been Lubrication Explained.